All right, we are on 10.8. By the way, make sure all homework is turned in. If it is not, it is late. Probability. Probability. All right, experiment. An occurrence. Hope I spelled that wrong. Right. Leading to one of several specified outcomes whose result can't be known ahead of time. Okay, what's the probability of this? What's the probability that we don't have any more interruptions this school year? We don't know. But that's what probability is. What's the probability? You know, it's based on like percent chance. What's the probability that everyone's going to make an A on this test?
0%.
No, that's wrong.
2 to the second power.
Oh my goodness.
Around.
All right, so there's some words that you need to know. You need to know what a sample space is. It's the set of all possible outcomes of an experiment. All possible outcomes. So if I were to say, what is the possibility that we will not have any more interruptions?
0.
Okay, so the probability would be either we have an interruption or we don't have an interruption. That's your sample space, the set of all possible outcomes of an experiment. Either we will have an interruption or we won't have an interruption. So those are the possibilities. You see what I'm saying? That's all the possible outcomes. Taylor, did you ever figure out what Quizlet I made?
Science. What? Yes, you're right.
You're right, Taylor.
So did you study it?
Oh. Well, that was why.
All right. Trial. Trial's a single observation. Outcome. Result of a single trial. Event. Possible outcome of a trial. Let y'all catch up. Okay. It's done this way. Probability. Oh, I'm doing good today. Of an event. It's going to be done almost like, it's going to be done like a fraction when you're solving these. On top, if you can't see in the back, move up. Favorable outcomes over possible outcomes. And I'll explain that in more detail in a minute. Basically, the desired outcomes over the total possible outcomes. So, for example, when I said, what's the probability of us not having an interrupted school day? Well, wait, what would go up on top? Well, how many total outcomes can I have? 2. We can either have an interruption or we don't have an interruption. So 2 on the bottom. But on top, how many, what would I have?
2.
What's my desire?
No.
9.
No.
So how many would I have?
1.
There'd be 1. No, I said for the rest of the school year. So if that was my question, my experiment, what is the probability of us not having another interruption?
50%.
Okay, or 1/2. So yes, 50%. Okay, does that make sense? Your total number of possible outcomes, well, in that case, there's 2, goes on the bottom. Favorable meaning what we want. My question was no interruptions. That there's only one possible outcome, then that would be up there. Okay, that's a good example. When you're done, put your pencil down so I know you're done. Okay, because if you're doodling on your page, I don't know if you're still taking notes. So let's do another example on paper. Let's say this is like a spinner. Hope you all are writing this down. And the question is, what's the probability of getting 2? Like the number 2. What is the probability of getting the number 2? Now remember up here, favorable over possible, desire over total. And I'm going to short it up by saying desire over total is what we're looking for. So what if this was a spinner and I like flicked the spinner and it was going around? What's the total possible outcomes that it could have? Whit?
4.
That's right. Thank you for raising your hand. But what's my desired probability? How many do I have, Joanne?
Like 1.
1. Okay. Joanne just hit. This is the correct answer. But Joanne did exactly what everyone does. You're looking for a 2. So you have that need to put the number 2 up here. Because it says, that's just like human nature. You just go to that. But what we're looking for is the favorable outcomes. How many outcomes? Well, there's only 1, 2. So then we put 1 up there. Okay? Now, your book asks for fraction and decimal form. Why it doesn't ask for percentage, I don't know. But what would be the decimal form of this? Raise your hand. Gabby? There you go. So in this case, we're going to have 2 answers. Most of the questions ask for both. If you're like, man, I can't remember how to get the decimal form. If you have forgotten, you're dividing. What goes in the house, the horse or the cowboy?
The cowboy.
Cowboy. 1 is the cowboy, 4 is the horse. You divide into that. 4 can't go into 1, so I put a decimal. Out of 0, 4 goes into 10 twice. I get 8. Add a 0, goes in there 5 times evenly. So if you have forgotten how to find the decimal, that's how you do it. Any questions? All right. What if along the same, using the same spinner, what would be the probability of getting an even number? So using the same spinner, what is the probability of this time getting an even number? So remember, we want our desire on top, our desired outcomes on top, and our total outcomes on the bottom. So how many total outcomes do we have, Cecilia? Possible outcomes. 4, very good. But we're looking for an even number, so how many outcomes would be even? That's right, 4 and 2 are even, so she's right. We would have 2 possible desired outcomes. Now, just like in anything else, we have to reduce that. So, Cecilia, what would that really be? If we reduce the fraction?
50.
Well, no, what's the fraction? You're right, but what would put this in lowest terms? Is there a number that can go into 2 and 4?
Mm-hmm.
What?
2.
How many times 2 go into 2?
1.
How many times 2 go into 4?
2.
This is what I'm looking for. Reduce your fractions. And you're right, Cecilia. The decimal is 0.50. So there's your 2 answers. 50%. Whit, did you have a question?
I do not.
Okay. Any questions about this?
Would you rather have it in decimal form or fraction form?
You gotta have it both.
Oh, both.
Just see what they're asking.
Okay.
All right, everyone have this?
Yes.
Moving right along.
Can we write that as 0.5?
You can write it however you want. It's the same thing. I mean, it literally is the same thing. Okay, you need to know what mutually exclusive means. 2 events can't occur at the same time. That's a V. Okay, so now we're getting into a little bit different sort of thing. Now, the first stuff that I showed you, it makes sense. And the only issue I think y'all are going to have is, like, the desired outcome was for just getting the number 2 and accidentally putting 2 on there instead of 1. Okay, to me, I think that's going to be the biggest mistake that y'all make. So I suggest y'all just slow down, take your time, and think about it before you throw it down. Because sometimes when we get in a hurry, we don't really think. Now this part's a little different. And you're going to have to remember this. To find the probability that one or the other of two mutually exclusive events will occur. Add their probabilities. Okay. This is what you have to memorize. Mutually exclusive, they're talking about two events, okay? Two different events or possibilities, probabilities. When they use the word or, you are going to add, okay? Because tomorrow you're going to be learning something different. So whenever you see the word or, you're going to add. That's what you have to have memorized. That's not much for a day of math, that's the only thing you really have to have memorized. That and the fact that desire goes on top, total goes on the bottom. We're not killing too many brain cells today.
I figured out how to never forget my mask again.
That's good.
Or I can be just
Me too. Because this one's cute and I didn't forget
Okay, there you go. I'm glad y'all are finding out. I'm glad I'm in the middle of teaching math and y'all are telling me all the ways that y'all are not going to forget your math.
Oh, I want my little cheetah mask.
Okay, no. Guys, stay focused. See, this is what I'm talking about. Y'all go on these little rabbit trails in the middle of me trying to teach. Y'all talk about, what are y'all not even thinking about what I'm teaching. Y'all thinking about your mask and all this other stuff and how cute your little, what is that, animal skin mask is. Okay, guys, stay focused. No, Taylor, put your hand down. You and your 3 donuts this morning. All right.
I had to.
Michael, come on, y'all. I'm going to talk to Mr. B about giving y'all all this sugar.
They're just gonna do it again.
Yeah, and we're learning about this in science, too. That was one of the questions. Is having a bunch of donuts and stuff good? Called a balanced diet?
Yes.
No.
Well,
The probability-
actually, it's an exception because
Okay, that's fine,
Our
but,
teacher
but
made
when
us
you're
do
eating multiple donuts, that's not good.
The president of the United
What?
States forced us to eat
The
donuts.
probability of Michaela forgetting her mask is 9 out of 10.
Wait,
Oh my
what?
God.
Current.
That means technically, you know how carbohydrates turn into sugar? That means it was pure sugar.
That's right. That's what I'm talking about.
Oh,
It was
just
pure sugar.
Like
That's why y'all thinking about masks instead of math. Okay, let's get back to this.
Ryan,
Okay, here we go. Listen. Shh, no, quiet. Here's my spinner, but this time, oh goodness, how am I going to do this? Okay, I have a few more in here. It's not going to be perfect. Ignore. Okay, yeah, that's way not perfect. Okay, just, pretend.
pretty good.
Thank you.
Wait,
How
are
many
they supposed to be
do you have?
even?
Yeah, they're supposed to be even.
Okay.
There's 5.
I got 6.
No. Okay, come on, Taylor, do it right.
I got 6.
Redraw it. And 3 of them are shaded. Come on, y'all, stay focused.
Uh-oh, that's...
All right, so here's your question. What is the probability, that's what the P means, of getting a white space or a number greater than 4? So we're taking it up a notch. So this is saying, what is the probability of getting a white space or a number greater than 4? It didn't say greater than and equal to, it just said greater than. And keep in mind, you see this or? That's correct. This means add. That's right. So every time you see or, that means you're going to add these two things. So let's talk about that. How many choices do we have for a white space, Michael?
2.
2. 1, 2. Do y'all see that? There are 2 white spaces, so I'm going to put a 2 here. How many numbers, Izzy, are greater than 4? That's correct. Number 5 is the only one that's greater than 1, and she's correct. She didn't say there's 5. See, do y'all see how it's easy to do that? She didn't say 5. She said 1. There's 1. She's not talking about this one. She's saying there's 1 choice for a number greater than 5. So we're going to put 1 here. Now, we know that it's 2 plus 1, but we have to write it in the form of our little fraction, desired outcome over total choices. So what would be our total choices in this case, Joanne? What's our total choices? 5. That's right. There's 5 possible outcomes if you spin the spinner. But what is our desired outcomes? How many would we have here, Michaela?
3.
3. Perfect. That's how you would do that. Are there any questions? Yes, Taylor, on math. We have 3 over 5. Does everyone understand that?
Are we gonna get the decimal?
Yeah.
Okay, did y'all get it?
No.
What did you get, Taylor?
0.6.
Does everyone agree?
Yeah.
Ah, very good. Good job.
Thank you.
All right, so let's open up our books to page 435.
What are we on examples?
You should already have your book open. You know what? I didn't even spell that correctly. Examples.
Examples. That's some pretty good apples you got there.
There we go. Examples.
I kind of want to try an example.
Exotic.
There you go. Examples. Exotic apples.
You created something, Sergeant.
Ah. Taylor, do you have a question? No, put your hand down. Okay. I'm looking to see, guys, y'all need to start opening your books up when we start.
Yeah.
Page 435. Aiden, please read the directions.
6 red marbles, 5 yellow marbles, and 4 green marbles are placed in a container.
Stop. How many red?
6.
Y'all should be, in this kind of stuff, you should be highlighting, circling, underlining something. 6 red marbles, 5 yellow marbles, and 4 green marbles. That is important information to be able to answer the questions below. So that should be highlighted, underlined, or circled in your book. All right, continue.
And 1 is drawn. Find each of the following probabilities. Express your answer as both fraction and a decimal rounded to the nearest hundredth.
That's important information too. So you should be highlighting, underlining, circling. You should have your answer in a fraction and decimal rounded to the nearest hundredth. You guys are famous for reading the first couple words of the instructions and then forget the rest. Make sure you do this, okay? It's a good habit to get into, not forgetting, but doing. All right. So they're asking, number 2, what's the probability of getting a red marble? Let's see. Izzy. What is your...
6.
Wait. You don't even know what I'm asking, girl. Remember, desire goes on top, total on the bottom. So, Izzy, what's the total? How many Okay,
Of all the marbles together?
well, all these marbles were placed in a container. What's the probability that you draw a red? So how many total marbles are we talking about? That's right. 15 total marbles. Remember, picture it in your head, all these marbles in the container. And the question is, what's the probability of reaching in and drawing a red? So how many desired outcomes are there?
6.
There you go. There's 6.
Bless you.
Depends on if it's at the top.
Now, Izzy, can you reduce that fraction, please? Are you just reducing this fraction?
Yes. And writing that. Last year I almost forgot my glasses at home.
Yes, I did. This.
Then you forget to wear your mask. So I wouldn't have no
Forget.
One over 5.
What number goes into 6 and 15?
I don't know.
Think about it.
Wait. Oh, 3.
How many times 3 go into 6?
2.
How many times does it go into 15?
5.
There's your fraction. Now, does anyone have the decimal? Cecilia.
0.4.
Perfect. There you go.
Nearest hundredth, right?
Yeah.
This is,
Did you work it out?
yeah.
What'd you get?
So don't we have to have the 0?
No.
Wasn't that 10?
But it's okay. They're saying if you did the division and you had a bunch of numbers, you would round it to the nearest hundred. But this is already fine. This is good.
Wait. So where's the tens place?
This is the 10th place.
You can't have a 1th place. That's
Wait.
the first.
I thought it said round to the hundredth place.
It does.
That's what I was just saying.
Okay, but that's saying if we had like
0.4257 6 2 3.
if we had something like that, they're saying round to the nearest hundredths place, but we don't. It's just this. It didn't go beyond, so you don't need to do any rounding.
Wait. So if we had that one, then it would be 0.4, or it would be 0.4 still.
It'd be 0.43.
Oh. Oh, I see.
So this right here is why I'm taking away calculators. This here is why I'm y'all not using calculators today. All right, 4, because we're having trouble reducing fractions. We're having trouble getting decimals.
Not
We're having
really.
trouble. Oh yes, we. You asked the same question.
What I was asking.
So
about
you're
the
grounded
I
from
was clarifying.
calculators.
I was clarifying.
You are grounded from calculators. All right, so let's look at number 4.
Oh,
Let's see. I want Gabby to read the directions.
A class contains 10 boys and 6 girls.
Okay, what's important information there?
10 boys and 6 girls.
There you go. Highlight, circle, underline, whatever.
not very related.
All right, continue.
Their names are put into a hat, and one name is drawn. Find each of the following probabilities. Express your answer as both a fraction and a decimal, rounded to the nearest hundred.
All right, what's important information there?
The fraction.
Fraction, decimal,
Rounded.
round if needed. to the nearest hundredth place. All right, so number 4. What's the probability that you draw a boy?
10.
Okay, excuse me.
Oh,
It's
sorry.
not your turn. This time I'm going to pick on
Me.
Taylor.
Yeah.
All right.
Okay, so
What's the total?
total is 16.
So you have a possible total of 16 choices. So that's your total.
And it's 10 on the top.
And 10 on the top.
This is diagonal outcome.
That's right, because we want to know how many boys.
And now you can reduce that by going 5 over 8.
Okay. 2 goes into 10 5 times. 2 goes into 16 8 times for those of you that have forgotten. And, Taylor, do you already have the decimal?
No, I'll try to get that. Okay, so
Well, for the sake of time, raise your hand if you've already got it. Gabby, what did you get first?
163.
Well, that's the answer. What did you get first?
0.625.
Perfect. Okay, those of you that question the round nearest hundreds, here's when we would do it. This number goes beyond the hundredth place. So we look to the right. That number is 5 or greater, and Gabby said, therefore, the 2 turns into a 3.
It was clarification.
Well, and that's what I'm doing. I'm clarifying, make sure y'all understand. Any questions?
related to this.
Yes, Taylor, related to math. All right, number 6. We're still using the same stuff, the same directions. But this time they want to know the probability of a boy or drawing a girl. Okay, there we go. We have that or. Joanne, what does or mean?
You add.
You add them. How many boys do we have, Joanne?
There are 10 boys.
And how many girls are there, Joanne?
16.
What?
Or 6.
There you go. 6 girls. So, if we add, what do we get?
16.
So then, again, we're looking for desire over total. So, Joanne, this time, what's our desire?
It's 16.
What's our total?
16.
And if we round that or, put it in lowest terms, whatever, what do you get?
Just 1.
Just 1. There's no decimal or anything. In this case, it's just 1. Any questions? You have a question or are you about to sneeze?
No.
Okay. Number 8. Michaela, read the directions.
For one spin, find each of the following probabilities. Express your answer as both a fraction and a decimal rounded to the nearest hundredth.
You should be highlighting, underlining, or circling. Fraction and decimal to the nearest hundredth. Okay, we're using that spinner off to the right. Does everyone see the spinner? Does everyone see the spinner in their book? If you don't, raise your hand. All right, number 8 says, what's the probability of an even number? All right, let's see, Cecilia, what's the total possible outcomes?
3. Oh,
Total.
6.
Very good. And how many even numbers?
3.
3. Now, Cecilia, reduce that, or put in lowest terms.
1 over 2.
Very good. And what's your decimal?
0.50.
Yeah. Or 0.5. Perfect. Any questions? I got just a couple more and then I'm setting you free. Y'all have it down? Y'all getting this? Don't forget you got IXL on this stuff too. All right. Number 10. This time we're using the same spinner, boys and girls, same spinner. This time, what's the probability of getting a number less than 6? They didn't say and 6. That's not less than or equal to. So it's not including the number 6. So what is the total? Let's see. Width.
6.
And how many desired possibilities do we have?
5.
Very good. Raise your hand if you get the decimal. Taylor?
23.
Perfect. So there's your 2 answers. Aiden, look at number 12. Read the directions.
If one square is drawn, find each of the following probabilities. Express your answer as both fraction and a decimal, rounded to the nearest hundredth.
Highlight, circle, underline, fraction, decimal, and round to the nearest hundredth. We're using those little cards with the letters on them. To the right, y'all see the yellow cards with the letters? You do not?
I said yep.
Oh, okay. So 12 is what's the probability of drawing an A? So Aiden,
Yeah.
what's my total choices? 8. Total possible outcomes 8. And how many desired for an A?
1.
Perfect. Do you have the decimal already?
No.
Okay, raise your hand if you got the decimal. Gabby? All right, because it's 0.125, we have to round to the nearest hundreds. That number is 5 or greater, so that 2 becomes a 3. Any questions? And again, you are not allowed to use calculators, you're grounded. Last one. Michaela, you want to read the directions?
Mhm.
Go ahead.
If one square is drawn.
Wait,
What
16.
16. A track contains 6 lanes numbered 1 to 6, and runners draw for 4 lanes before a race.
Okay, so what's important information here?
1 to 6.
1 to 6. So that would be highlighted, underlined, or circled.
Find each of the following probabilities for the first runner who draws a lane. X represents the number of the lane drawn. Express your answer as both a fraction and a decimal rounded to the nearest hundredth.
Fraction, decimal, round to the nearest hundredth. Okay, 16 says, what's the probability of getting a lane 5? What's the probability of the runner drawing lane 5? So, Michaela, what's the total possible outcomes?
6.
Perfect. Yeah, 6. Lanes 1 through 6. And how many desired outcomes will we have by choosing 5, lane 5?
1.
1. That's right. There's only one lane 5, so it's 1 over 6. Raise your hand when you got the decimal. I'm going to let someone else go, but besides the one that just answered before. Someone that hadn't had a turn.
I'm fine.
.17.
Did you raise your hand?
Oof.
0.17. Aiden was there. Aiden was there. It was 1.166, but if we round to the nearest hundreds, it would become 7. All right, y'all are doing page 435 to 436. That's right. You are doing all of that.
All of it?
No, I'm just kidding. You're doing
7, 23, 89.
numbers 5 through 17 odd. Yeah, why not? And, oh, this is going to be good. 27 to 31 odd. This is due Friday. Nice try. IXL is due Wednesday. And your test
It's 10 problems.
is Wednesday. Alright. Get started. Don't run, Taylor. See what happens?
He forgot
And
his
you
glasses.
don't have your mask on. Thought you said you're going to not forget.
I took it off my glasses because it gets annoying.
You need to put it